Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
So today we're going to be working with the intermediate value theorem. Firstly, the IVT states that if a function is continuous on a to b, and if L is any number between f of a and f of b, then there must be a value x equals c where a is less than c is less than b, such that f of c equals L. So first, we're going to be looking at the graph on the bottom left, and you see that 2 points are plotted, a comma f of a and b comma f of b. And on the right, you see a continuous function. The IVT states that f takes on every value between f of a and f of b. So an important factor in this is that it has to be continuous in order for the IVT to apply. So let's look at 2012 multiple choice question number 77. Let f be a function that is continuous on the closed interval from 2 to 4 with f of 2 equal to 10 and f of 4 equal to 20. Which of the following is guaranteed by the IVT? So first, what's important to note is that it is a continuous function. And next, we're going to graph it. So our first point is 2 comma 10. And our next point is 4 comma 20. And next you can just draw any continuous function. Mine looks like this. And now we're just going to go from bottom to top and figure out which answer applies. So E says f prime of x is greater than 0 for all x in the open interval. Well, just looking at this graph, this portion right here, it's decreasing. So that means the slope is negative. And that would cancel out this. If you need more help on this, you can actually go to 5.9, connecting derivatives, which helps with dealing with slopes and stuff, but I'm not going to get into it as far. So from here, we know that E is not the right answer. Now looking at D, it says f prime of x equals 5, has at least one solution in the open interval. The IVT doesn't really deal with primes, therefore derivatives, but this could apply. It just isn't guaranteed by the IVT. So this could apply if it said an MBT, and if you need more help with that, you can go to 5.1 MBT. So we know that it does not apply for the IVT. Next, C discusses minimums and maximums, saying that f attains a maximum on the open interval from 2 to 4. Again, this isn't really applied by the IVT. The IVT is more talking about existence, so we know that this isn't our answer. Now it's just between A and B. So between A, it says f of x equals 13 has at least one solution in the open interval from 2 to 4. And B says f of 3 equals 15. We don't know for sure what value x has at 3. We don't know that it's 15. So therefore, A implies that it has to take on the value of 13 somewhere amongst the interval. So this would make A being our right answer. Next, we're going to look at 2016 Frq Question 1, Part D. So first, we're going to start off by not concerning ourselves with any other question. And if you want to take a minute and read that through, pause it. But a big factor in this is that it says differentiable. And differentiability implies continuity. So we're going to go into the next slide and figure out what the question is asking. So it asks, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? So basically this question is asking, when, if any, does W of t equal R of t? So first we want to see if this value exists. So first you want to look at your two endpoints, which is 0 and 8. So plug in 0. So W of 0 minus R of 0 is greater than 0, and W of 8 minus R of 8 is less than 0. So if one is greater than and one is less than, that means you have to have a value in there where at some point it has to equal 0. So to finish off this question, you would say, therefore, the IVT guarantees at least one time t, 0 is less than t is less than 8, for which W of t minus R of t equals 0, or W of t equals R of t. So now by looking at the scoring guidelines, you get 2 points if you consider that W of t minus R of t. So we did that on the left side, comparing 0 and 8. And on the bottom, we had our answer with an explanation. This was 1.16, working with the intermediate value theorem.